What if I told you that everything you believe about space and time might be wrong? Sounds strange, right? But science has already proven that the universe isn't a rigid, unchanging stage like we once thought. Space can bend, time can flow differently, and even light can change its path. The most surprising part? This doesn't just happen in distant theories. These discoveries shape your daily life right now, even if you've never noticed. Newton looked at a falling apple and saw more than just fruit hitting the ground. He saw a universal law. Gravity, according to him, was like an invisible hand pulling everything toward everything else, keeping the planets orbiting the sun just as it kept our feet firmly on the ground. This simple yet powerful explanation turned the chaos of the skies into something predictable, almost like a giant cosmic clock. Imagine being able to calculate the movement of a comet or predict the next eclipse using nothing but pencil and paper. Newton made that possible. For more than 200 years, his theory was the unquestioned queen of science. Engineers, navigators, and explorers relied on his laws to cross oceans and measure unimaginable distances. It was as if Newton had handed the world a cosmic calculator, and everyone trusted it without hesitation. Even today, if you throw a ball or build a bridge, it's classical gravity that ensures everything works just right. No wonder his Principia Mathematica was called the Bible of Science. But, like every great story, cracks began to appear. Small inconsistencies in certain celestial movements showed that perhaps the explanation wasn't as final as it seemed. Mercury, for instance, had an orbit that didn't quite fit into Newton's puzzle. And it was through this tiny gap that another genius would step in, ready to completely redraw our view of the universe. The year 1905 became known as Einstein's Annus Mirabilis, or miraculous year. In just 12 months, he published papers that forever changed the way we understand reality. Special relativity was the crown jewel of that period, shattering the idea that space and time were absolute. Suddenly, what once seemed solid and eternal revealed itself to be flexible and relative. It wasn't just a complicated theory, it was as if someone had swapped the lenses through which humanity saw the universe. Einstein invited us to imagine scenarios that sounded like science fiction. Picture twin brothers. One stays on Earth, while the other travels through space at nearly the speed of light. When the traveler returns, he discovers he has aged less than the brother who stayed behind. This is the famous twin paradox, a direct consequence of special relativity. What once belonged to imagination became the foundation for technologies we use today. Time was no longer a universal metronome, it depended on speed and perspective. These thought experiments were far more than intellectual games, they revealed a new blueprint of the cosmos. Einstein showed that energy and mass were two sides of the same coin, captured in a formula so famous that even those who never studied physics recognize it, E=mc². This vision sent shockwaves through science, paving the way for an even deeper understanding of gravity. And it was right at this point that Einstein experienced what he called the happiest thought of his life. Einstein often said he had the happiest thought of his life when he realized something simple but revolutionary. There's no difference between being in free fall and standing still in a gravitational field. To him, gravity and acceleration were two faces of the same phenomenon. Imagine yourself inside a falling elevator. What would happen to the objects around you? They'd float, as if gravity had vanished. That insight reshaped our understanding of reality and opened the door to general relativity. The famous elevator thought experiment makes this idea easier to grasp. If someone were inside a windowless elevator, they wouldn't be able to tell whether the force they felt was due to gravity or constant acceleration. This tiny detail revealed that gravity wasn't just an invisible pulling force, but something deeper, woven into the very fabric of the universe. It was as if Einstein had discovered a master key that unlocked hidden dimensions of physics. And this principle of equivalence didn't remain trapped in theory books. It inspired real experiments, from drop towers to airplanes simulating zero gravity. Even NASA applies concepts derived from it to train astronauts. It's fascinating to realize how a spark of imagination in one man's mind ended up guiding our technology and exploration. But Einstein didn't stop there. This was only the prelude to an even bolder discovery: gravity as the curvature of space-time. Einstein went a step further by claiming that gravity wasn't an invisible force pulling bodies, as Newton believed, but the result of space-time bending. Picture the universe as a giant elastic fabric, where planets and stars create dents in that fabric. So when Earth orbits the Sun, it isn't being pulled, it's sliding along the curve. This idea sounded almost poetic, but it was backed by rigorous math that forever changed physics. The trampoline analogy makes it easier to see. Place a bowling ball on a trampoline, and the fabric sags, creating a curve. Now roll a marble nearby, it spirals around the heavier ball, trapped by the dip. That's exactly what happens in the cosmos. This explanation solved mysteries Newton's theory couldn't, like Mercury's strange orbit that seemed to wobble in a way no formula could explain. This triumph of general relativity showed that the universe was far more dynamic and flexible than imagined. It wasn't just about gravity anymore. It was the very stage of space and time being shaped by celestial bodies. Suddenly, concepts once thought unshakable turned out to be bendable, giving science new eyes to explore the cosmos. But still, a practical test was needed, something undeniable that would prove Einstein right before the world, and that moment arrived in 1919, during a total solar eclipse. In 1919, Einstein went from being a brilliant physicist to a global celebrity. And it all happened thanks to a rare event, a total solar eclipse. He had predicted that starlight would bend as it passed near a massive body like the Sun, precisely because of spacetime curvature. The theory seemed too bold to accept without proof, but the eclipse offered the perfect chance to test whether light really bent. That's when astronomer Arthur Eddington led an expedition to Principe Island, off the coast of Africa. During the eclipse, when the moon blocked the sun's glare, scientists photographed stars appearing near the sun's edge. The analysis showed their positions were shifted, exactly as Einstein had predicted. It was as if the universe itself had signed its name, confirming that gravity was indeed the curvature of spacetime. News of the discovery spread worldwide, and Einstein became a household name, gracing newspaper and magazine covers. A theory once considered abstract suddenly felt tangible, almost cinematic. Ordinary people, who had never cared about physics, were amazed to learn that even light could bend. And this wasn't just a scientific victory, it opened the door to a new era, one where relativity would move from theory into our everyday lives. It may sound distant, but relativity is built into things we use every single day. Take the GPS on your phone, for example. It only works because the satellites orbiting Earth adjust their clocks to account for relativistic effects. Up there, time runs just a little differently than it does down here, and without that correction, your location on the map would be completely wrong within minutes. It's as if Einstein left his invisible signature on every route you take. This fascinating detail shows that time isn't the same everywhere. In satellites, it runs slightly faster than on Earth's surface, and though the difference is tiny, it's enough to throw the entire system into chaos without relativity's math. Think about it, a theory over 100 years old sits at the core of the technology guiding drivers, planes, and even delivery apps. What once sounded like pure philosophy became part of daily life. But relativity reaches far beyond GPS. It allowed us to understand black holes, predict the existence of gravitational waves, and explain how light bends into cosmic lenses that reveal hidden galaxies. Each breakthrough proves that Einstein didn't just explain the universe, he gave us the tools to explore it. And if these discoveries have already transformed our world, imagine what secret spacetime still holds, waiting to be uncovered. Now that you know the secrets of space-time, let me ask you, what will you do with this knowledge? Will you just find it interesting, or will you use this new perspective to see your own life differently? If time itself can bend and light can change its path, why should you believe that you're stuck where you are? The universe shows us that everything is movement, transformation, and possibility. Think about it. How many times have you accepted limits just because someone told you they were unbreakable? Einstein proved that even unchangeable laws could be questioned and rewritten. What if the same applied to your personal, financial, or emotional beliefs? Maybe it's time to bend reality in your favor, just like gravity bends the light of the stars. So here's my challenge: what's the next step in your journey? If you've stayed with me this far, it means you're hungry for knowledge and brave enough to go beyond the obvious. Don't let that spark fade. Subscribe to the channel, turn on notifications, and keep exploring with me the greatest secrets of the universe, and maybe, the greatest secrets of your own life.